X-rays, what are they used for? We use X-rays to see broken bones. What happens to waves when you increase and decrease the frequency? Oh, we've already talked about that. If you increase the frequency, the speed does not change, but the wavelength does exactly the opposite. So if you increase the frequency, the wavelength has to decrease. And the amplitude is determined by the energy that the wave starts with. I would suggest, again, making some diagrams where you compare these things. In fact, your body needs ultraviolet light to make vitamin D. Just standing outside in the sun, you actually get some vitamins. Moving on down the list. Compare the speed of sound in solids, liquids, and gases. Make a diagram. Remember that in gases, the molecules are very far apart, and that means the energy moving from one molecule to another can only happen when they collide with each other. They have to move space to get to one another. Liquids, the molecules are closer together, actually kind of touching each other and sliding back and forth across each other. And in solids, they're locked together. In crystalline solids, they're the closest they can possibly be. So when sound moves through these three mediums, it goes very slow through a gas, it's faster through a liquid, and it's the fastest in a solid. For comparison, in air, sound will travel at 340 meters per second. In a liquid, it travels approximately 1500 meters per second, and through steel, it approaches 6000 meters per second. What are the factors that change the speed of a wave? That can only be the medium. The medium is what determines the speed of the wave. Define resonance and why do we use it in musical instruments? Or why do musical instruments need it? Resonance is when a object has a natural frequency that it vibrates at, and if you vibrate that object, it will reinforce that sound. The sound bodies, like the bodies of violins and guitars, they amplify the sound using resonance. And you should look up that definition for resonance. You should also define refraction and make a diagram of that. Since that's something you can easily look up, I'm going to move on. List the characteristics of sound waves and make a diagram. Sound waves have to have a medium. They're longitudinal waves, which means that the medium and the energy are moving in the same direction. The material, whatever the medium is, it just shakes left and right a little bit. The energy moves a long distance. And you can't have sound in a vacuum. It has to have air to travel through at least. What has to be moving for the Doppler effect to occur? The Doppler effect only occurs if the person observing the sound is moving or the source of the sound is moving. The Doppler effect is a change in pitch as something passes by you. Think about a train or a race car. We have a pitch change. As it's approaching you, the pitch is higher, and as it passes you, the pitch is lower. Gamma rays have so much energy that they break down molecules and cells in living organisms. This is true. And gamma rays are so powerful they can actually disrupt DNA in living organisms and cause mutations, or usually death. Which EM wave or electromagnetic waves are most often used for communications? We've already discussed this, but that's going to be a radio wave. Ultraviolet light can cause sunburn. Write that down, make sure you know it. When you think about different kinds of light, incandescent light bulbs, the ones with the filament on the inside that gets hot and glows like Thomas Edison invented, those are not very efficient. Most of the energy is used to make heat, not light. So most of the energy you put into that kind of light bulb is lost as heat. Very little light is actually produced by an incandescent light bulb. Fluorescent bulbs are much more efficient because you're passing an electric field through a gas and causing the gas to emit light. So you don't have as much heat and you have a lot more light produced. And the material we are using needs to be updated because LEDs are the most efficient light bulb of all. So you could make a diagram of each one and put the least efficient to the most efficient. These are definitions. I'm going to very quickly talk about them. In your definition of temperature, it should talk about average kinetic energy. In your definition of viscosity, it should talk about resistance to flow. In your definition of sublimation, it should talk about going directly from a solid to a gas. And for plasma, it should talk about high energy atoms. When we're talking about the heat of vaporization and the heat of fusion, we're talking about things evaporating and things melting. So where those phase changes are occurring, find definitions that explain that. Another fact you should jot down, crystalline solids have the smallest distance between its molecules. Why do quarks float in water? It's a question of density. The quark has a lower mass per volume than water, which means that if you put it in water, it's going to float because water has a higher density than a quark. Does evaporation require the input of energy? Yes, it does. That is the heat of vaporization. It has to absorb so much heat before it can go from being a liquid to a gas. Describe the differences between solids, liquids, and gases. Make a diagram. We've already kind of discussed that when we were talking about how sound waves move, but gases, so you need to look this up. There's probably some really helpful tables you can find online. Gases will take the shape of their container. The molecules are far apart. Liquids will take the shape of their container and their molecules are closer together. They won't spread out. They kind of tend to settle at the bottom. And solids do not take the shape of their container because they're solid. The molecules are very close together and tightly bound to one another. How does matter change when it's heated up? Generally, like think about if you heat a piece of steel up, generally that metal will expand. Airplanes fly, whose principle explains how this happens. This is Bernoulli. Bernoulli's principle explains how airplanes work. As air travels under a airplane wing and over an airplane wing, the air going over the top has to move further and therefore faster, and that generates lift. When you heat a gas, what does it want to do? And how could this be dangerous? As you heat a gas, it wants to expand. And if you put a closed container in a high temperature environment, then it's going to expand and possibly rupture the container. Physical versus chemical. You need to list physical and chemical properties. Make a diagram. So the properties are things like density and mass and the ability to react with oxygen and things like that. Identify examples of physical and chemical changes. The physical changes are changes that occur where when you're done, you still have the same material that you started with. Chemical changes, when you apply a chemical change, you have a change in what the substance is. So again, go through your notes, find some diagrams for this. How are mixtures different than compounds? Mixtures are just two things that are physically combined and they can be physically separated. Compounds are chemically combined. What sort of things could you separate with a magnet? Anything that's magnetic. A popular thing to think about is putting like iron, like BBs or something in sand, and you could use a magnet to get the iron out of the sand. You'll see this like a lot of times when they roof a house. There will be nails all around the house, and they have a little magnet on wheels, and they push it through the yard, and it picks up all the nails using the magnet. This is a form of separating a mixture of grass and nails. You need to be very familiar with the periodic table, but before you begin that, we need to talk about where's most of the mass of an atom, and this is Ernest Rutherford's experiment. He determined that the mass of the atom was concentrated in the nucleus, and that most of the space around atoms is empty. So it's like a very tiny, dense mass in the middle. You need to know the characteristics of metals, nonmetals, and metalloids. Metals, they're shiny, they're conductive, they're malleable, they're ductile. That means you can hammer them into flat sheets and you can stretch them into wires. Nonmetals are the opposite of that. They tend to be dull. A lot of them are gases. They don't conduct electricity, and they tend to be, they're not ductile. You can't make wire out of them. Metalloids are somewhere in between a metal and a nonmetal. They have characteristics of metals, like they can conduct electricity a little bit, but they're more like nonmetals in that they're very brittle and they are not ductile or malleable. Know the names, locations, and facts about special groups like the alkaline earth metals, the alkali metals, halogens, noble gases would be another one to think about, transitions metals, the, what do we call the series at the bottom? Oh, you'll have to look that up. It's not on the test. We're not going to worry about that. Know the regions of the periodic table though. So we don't need to worry about the actinide and lanthanide series. I did not put that on your final exam. So know about alkali metals, alkali earth metals, and the halogens, noble gases, and transition metals, and that will get you through the exam. What's the most reactive element?